Hello, welcome to 2.2. I know it says 1.5, but this is because this unit is just basically a collection of random different Algebra 1, Algebra 2 concepts. I kind of went back in time and grabbed some of the materials from the Algebra 1, Algebra 2 books. I believe this is actually from the Algebra 2 textbook. And what we're covering in 2.2 for our class is actually covered in 1.5 in Algebra 2. So that's the reason for that. But anyway, we'll cross it off. We'll just label it 2.2. Why not? So we're rewriting equations and formulas in this one. So it's a very important concept that we've done before. We've done it in Algebra 1. We've done it in Algebra 2, obviously. And we have to do it again here. It's just one of those things that pretty useful, something we need to do. All right, so it says work with a partner. A landscaper purchases gasoline for various lawn care equipment. Consider the following quantities involved in this situation. So number of gallons of gasoline, price per gallon of gasoline, total cost of gasoline. How are these quantities related in this situation? How can you represent this relationship? I don't know how to answer this necessarily because I know that B and C sort of take this as well. But so I don't know how to really answer A without kind of also answering B at the same time. But basically, we understand that our total cost, right, is essentially going to just be the number of gallons times the price per gallon, basically. And that's essentially the answer we put in B, write an equation that represents the relationship. So that is the relationship, right? The equation, of course, is the cost is equal to the number of gallons times the price of gallons, as we have so clearly mentioned. So I don't know how to really separate A and B differently. Other than that. So write two more equations that represent the same relationship. How did you write these equations? So now we're going to talk about price per gallon. So based on the other two, right? Price per gallon, how could we calculate the price per gallon if we have the other two bits of information? And the way we would do that is we would do total cost divided by the number of gallons, right? If we take the total cost divided by the number of gallons, we would get the price per gallon. If we want to know the number of gallons of gasoline, we could take the total cost and divide it by the price per gallon. And we could see how many gallons of gasoline we fill up with. So why do you think it's beneficial to have solved an equation for each quantity? Well, because, given different unknowns, we have formulas to solve them. So if the price is unknown, I can still calculate it if I know the total and the number of gallons. Or if the number of gallons is unknown, I can take my total price and divide it by the price per gallon. So this one would kind of work in like a scenario where, hey, I go to the gas station, I've got $40, how many gallons can I fill up with? Well, you can take your $40, you can divide it by the price per gallon, and you can see how many gallons you can fill up with. So, it works that way. It works that way. So here on E, it says after pumping gasoline, the landscaper sees the screen shown on the pump. Which quantity is missing? Find out the missing quantity and explain how you found it. So the price per gallon is the quantity missing. We have the total cost is 11.84, and the number of gallons is 473.8, right? So what we don't know is the price per gallon, but we can find it by taking the total cost of 11.84 and dividing it by the number of gallons of 4.738. And by doing that, we can, of course, then calculate our price per gallon. And don't be surprised, this one's going to be extremely cheap because for almost 5 gallons of gasoline, it's not going to cost $11 these days. So, but 11.84 divided by 4.738 is about 250 a gallon, 249.9, 2.499. So yeah, gas isn't quite that cheap these days, but you know, it goes up and down a lot, right? All right, so now let's get to the nitty-gritty part of our notes today. So rewriting literal equations. So here's a couple examples already worked out for you. So I'm going to kind of talk you through them, and then we'll kind of like do a couple on our own. So solving the literal equation 3y plus 4x equals 9 for y. So let me explain, like, let me zoom in on this a bit so we can see what it is. Here's what's going on. When it says solve the equation for y, what it really means you're doing is just rearranging the equation so that y is left by itself. So y equals whatever. Now, don't expect to get y equals a number. We're not trying to figure out what number y is, because if we don't know what number x is, then we can't find out what number y is. So instead, what we're doing when we're quote solving for y is just really just trying to get the y isolated, the y by itself. So in this process, you can kind of see it's worked out already, but in the process, what we're trying to do, here's our y. We're trying to essentially get rid of this 4x and relocate it to the other side of this equal sign, you know, the side that the 9's on. And we're also going to be taking that 3 and relocating it to the other side as well. If you get rid of the 4x and you get rid of the 3, then the y is the only thing left there. And so that's going to be the process. So you can see the first thing that they do in the first step is subtract the 4x on both sides. The reason they do that is because 4x minus 4x, this is going to equal 0 and cancel out. But because they do it on the left, they also do it on the right. Now, also keep in mind that because these are not like terms, right? They don't combine. You just leave 9 minus 4x. Okay, it's not 5x, it's not 5. They don't combine because they are not like terms. They're completely separate terms. So they just sit next to each other. But once the 4x has been canceled out, you can see, well, I say canceled out. It's canceled out on the left side, but now obviously it's placed on the right side. But after that, now the goal is to get rid of the 3. So they divide by 3 because they're trying to turn 3y into 1y. And to turn 3 into 1, you can divide it by 3. 3 divided by 3 creates 1. So since 3 is being multiplied to y, to cancel it out, you do the opposite, which is divide by 3. So you're always essentially doing opposite. Like you saw the plus 4x in the original problem. So what do? We do the opposite, which is subtract 4x. So that's how we get rid of it. We see it's plus, so we do minus 4x. Now here I see a 3 multiplied to y, so I do the opposite, I divide by 3. And so that cancels the 3 out. So now you can see the y is by itself. It's the only thing on the whole left side of the equal sign. But let's see what happens on the right is we divide these by 3. You could leave it like this. This would work just fine. But as you can see, they take it a step further. They divide individually. 9 divided by 3 turns into 3. They also show us that negative 4x over 3 is, well, negative 4x over 3, or negative 4/3 x. So this is still technically okay, but you can simplify it just a tad to this as well. These are pretty much the same thing, just slightly simpler answers. So there it is. That's the equation. It's the same equation we started with, but it's rearranged so that the y is by itself. So that's what it means, like I said, when we solve for y. If you look at equation 2, it's pretty much the same thing, same story. You're solving for x. But this one's a little bit trickier because you have x twice. So you're going to have to sort of combine them. And so one thing that we do is sort of anti-distributive property in a way, is we take the x out of both terms and we put it in the front. So see how, hopefully you can see the connection of how these two work together. Imagine we were going the other way, right? You would take this x and distribute it. You would multiply it to 3 and you'd multiply it to 5z. And if you did that, you would end up with 3x and 5xz, right? So you're doing essentially the opposite of distributing by pulling it out. You're taking the x out of the two terms and you're relocating it here. And then, of course, since it's no longer in the two terms, well, you can see the two terms are there without the x now. So it's It's the same thing as distributive property, but sort of backwards, right? The opposite effect. And so now at this point, the x is sort of by itself, but you have to get rid of this 3 plus 5z. And because just like the 3 on the y before, how this 3 is being multiplied to y, right? It's 3 times y, and we divided. Well, this is being multiplied to x, so you can divide it. You can divide that whole chunk. It's in a parenthesis group, so you can divide the whole chunk. So you can divide 3 plus 5z by 3 plus 5z. That whole thing is being multiplied to x, so therefore that whole thing can be divided. And so you can see they divide it on the other side as well. And what ends up happening is they'll cancel each other out on the right. And on the left, this is what we have. You can try to simplify it, but there's really nothing you can do to simplify it. So it's just going to end up staying that way. The y on the top and then the 3 plus 5z on the bottom. But the main thing is, again, the x is by itself, which is the whole point of this. So that's how we get to that one. All right, let's try a few on our own. So solve the literal equation for y. So we're going to do this for y. So with number 1, zoom in a bit on it. We're trying to get the y by itself, which means we'll have to move this minus x over. We'll have to move this 3 over. We get rid of those things, we'll have the y by itself. So the first thing we do is always anything that's being added or subtracted. So in this case, the x. So you can see we have a minus x. We are subtracting x. So in order for us to move it, we have to cancel it out, which means doing the opposite of minus x. So the opposite of minus x is plus x. So I'm going to do that to the left side. And when I do it, it cancels out, right? Minus x plus x are opposites of each other. They cancel out. But of course, you see I do it on the right side as well. So on the left side, with the x gone, it's just going to be 3y, right? So we're getting closer to having the y by itself. On the right side, I have 9 plus x. Remember, these are not like terms. 9 is a constant, and x is just an x term. So you can't really combine them, so we just kind of keep writing them out. 9 plus x, okay? They don't go together as one, they just stay separate. 9 plus x. So then, you can see from our example 1 from earlier, we have 3, and it's being multiplied to y. So we want to cancel the 3 out. We do the opposite, which is dividing by 3. So we're going to divide both sides by 3. And so we're going to have the y all by itself because the 3 divided by 3 will cancel out. But what does it equal? It equals 9 plus x divided by 3. Now you could probably leave it like this, which would be fine, or we'll do what they did in the example and divide it individually. So 9 divided by 3 will turn into 3. And then x divided by 3 will just be x divided by 3. And so technically both of these are fine. That version of it and this version of it, they're both right. However, I just want you to know that you can write it both different ways, just in case you need to know it that way for your skill checks or quiz or test or something. So but we're going to leave it as this for a definite final answer because that's what they showed us in the example to do. So if we look at 2, we can do the same thing. We're going to solve for y again. So that means getting rid of the 2x and then this minus 2. So this one's a little trickier. We'll talk about why as we get through it. But the first thing I'm going to do is get rid of the 2x. Now, I'm doing this essentially because it's kind of the furthest thing from the y. It's not being subtracted necessarily because the minus 2y is being subtracted, but I'm getting rid of it because it's a completely separate term than the 2y. So I need to get rid of it. How do I do that? Well, a lot of people look at this minus sign and think that we're subtracting the 2x. Again, that's not the case. You're not subtracting the 2x, you're actually subtracting the 2y. So that subtraction sign is not really relevant right now. This 2x is what I want to get rid of, and it's currently a positive 2x term. So for it to disappear, I'm going to need to subtract 2x from it. Because think about what will happen. What is 2x minus 2x? 0. It's going to cancel out entirely and just disappear. So that's the reason I'm going to be subtracting, because that's what I want. Now keep in mind though, because I did that on the left, that I also do it on the right. So on the left, as we mentioned, 2x minus 2x becomes 0. It cancels out. So on the left, it's going to leave you, you still have the negative, the minus sign there, 2y. That's still all there. But on the right, you'll see, well, I have 5 minus 2x. And just like the other problems, these are not like terms, so they don't combine. You just keep them separate, 5 minus 2x. All right. So now, again, the problem is I think a lot of people still think this is subtraction. You can't look at this minus sign as subtraction anymore because there's nothing in front of it. So really you have to think of it as a negative, okay? So it's really more of a negative 2 times y, similar to 3 times y, right? And just like the 3 times y, we're going to do the opposite of negative 2 times y, which is going to be dividing by negative 2, right? If negative 2 is being multiplied to y, well, then I need to divide negative 2 to cancel it out, because dividing is opposite of multiplying. So the negative 2 will cancel, leave you y by itself. And on the right-hand side, you'll see we'll have this, 5 minus 2x divided by negative 2. We can do this kind of one at a time as well. So 5 divided by negative 2 would be just negative 5/2. 5 divided by 2, and it's negative. And then this one's interesting. You have negative 2x divided by negative 2. So in that one, negative 2 divided by negative 2. Hold on one second. All right. Anyway, they had to deliver stuff to the door. So where was I? So we had negative 2 divided by negative 2. And that turns into positive 1. And negative divided by negative turns into positive, and 2 divided by 2 turns into 1. So this becomes a positive 1x. So plus 1x, or you could just write it as plus x. So this would be its simplest form right here. Negative 5/2 plus x. So that one's definitely kind of tricky. And when I say that this is a negative 2 instead of a minus 2, and like think of this as a negative instead of subtraction, think of it like this, right? You couldn't imagine this originally written as 2x plus negative 2y, right? Equals 5. That might help if you think of it like that, right? You have this adding a 2x, so therefore that's why you subtracted it. And then you have this negative 2 attached to y that you have to divide by. So if you imagine the problem like this, maybe it's a little bit easier to understand why we do the things that we do. This is essentially the same thing. Adding a negative will turn into this minus sign, but maybe visualizing it this way just helps you understand why we did what we did. All right. I'm going to do a couple of the x ones. Just again, I want to make sure we have time to kind of move on. So solve the literal equation for x. So remember, we have x in both terms. So if you remember from the example, we're going to take the x out of both terms. And so what I'll do is I'll have x on its own taken out of these terms, leaving me just with 5 minus 4. Now, in fact, I can actually go ahead and simplify that. I didn't see that the first time, but I can go ahead and simplify that. So 5 minus 4 is 1. So this is y equals x times 1. And, well, really, if you divide by 1, you don't really change a whole lot. So ultimately, you end up just with y equals x. Yeah, I mean, I'm not going to do it differently. I think that's just, it's almost too simple that it's confusing. Let's do number 5, and maybe we can see a little bit more differences, right? So again, notice that there's x here and an x here. So we're going to do the same thing. We're going to take them out and put them in the front, so the x's will go away. And that leaves you with a 2 and plus k, right? Still with the equals m as well. That's still here. All right, and just like we saw in the example, we're multiplying the 2 plus k to the x, right? That's how distributive property would work. It's x multiplied into this normally, but of course we just did the opposite to take it out. But you are multiplying that group to x. So in order to cancel it out, we would divide by this, because that's the opposite of multiplying by that. So dividing by the 2 plus k, just like we saw in the example, cancels out the 2 plus k. So x is equal to, well, as you can see, m divided by 2 plus k. There's nothing you can do as far as simplifying it goes. Because you have the plus sign in the denominator instead of the numerator. So if you see the plus sign in the denominator, you can't really do anything to separate them. So it's just gonna have to stay that way. So that is it. It's really just a couple steps. Seems more complicated than maybe it really is. All right, so let's do number 6 as well. So now this one's a little bit more interesting because there's not an x in every term. There's only an x in these two terms. So what I would actually end up doing first is I would get rid of this 3. I would subtract the 3 just to move it out of the way. So it's currently a positive 3, as you can see, which is why I'm subtracting it, because 3 minus 3 will turn into 0 and go away. So to fix this, I'll just have that 3 cancel out and I'll have 5x minus kx. And then it'll equal, as you can see, y minus 3. Because again, the y and the minus 3 don't combine, so you just kind of keep them separate, just as a y minus 3. All right, so we'll do what we were doing before, talked about before, where I take these x's out of the two terms, and with them out of the two terms, I have just 5 minus k remaining. And again, just like our example and just like the last problem, we're going to divide by 5 minus k in order to cancel it out. So of course we do this again to both sides. So my final answer, with it completely canceled out, is we're going to have y minus 3 divided by 5 minus k as my final answer. The rest of these problems are pretty much the same story. It's just they're used more formulas instead of just random equations. So as you can see with this example, you have a formula for the surface area of a rectangular prism. There's a formula given, and it just says solve for L. So as you can see in this one, it's kind of like number 6, the problem we just did. It's kind of like that. You have the L in these two terms. So we will take the L out of these two terms, right? But before we do, we're going to move this term that doesn't have the L in it on the other side. So you can see because it's a plus 2WH, that they're subtracting 2WH in order for it to cancel out. And so that's why you see the minus 2WH on that side. You're moving that over. And then, as we mentioned, we have the L in both these terms, so it comes out. And when the L comes out, you can see that that leaves you with a 2W and a 2H. So then you divide by that 2W and that 2H, and you can see, well, once you have that divided on both sides, how it cancels out on the right, and well, this is what we end up with on the left. And that's it. It looks like a hot mess, but you can't simplify it. It's going to have to stay that way. It's not much more you can do. So really, again, this is exactly the same as number 6 in terms of the process. There's really only 2 steps involved. Step 1, cancel out this term and have it move to the other side, which is just like how we did it with the 3. We canceled out the 3 and moved it to the other side. And then the second step is moving the L by itself and dividing the part that was left over. So, and we did that with this as well, because we took the x by itself and we divided away what was left over, the 5 minus k. So it's almost exactly the same process, really the exact same process, number 6. It looks like a more complicated process than it is because they show every step in full detail, but it's really just 2 steps. All right. And this one's the same. They give you the formula, they have you rearrange it, but the only difference is you plug in the numbers. So once you've got your formula, you just plug the numbers in that you need to plug in and you can solve. That's pretty much it. Yeah, there's a couple more examples. There's one with the Fahrenheit and Celsius. Again, a similar story. Maybe we can try that on another day, but yeah, for now, I think you guys get the main points of it. The only difference is the examples just do it with different versions of different formulas. So the I equals PRT formula, which we saw in an earlier section, is here. Yeah, you can do it with any formula. So this just practices it with different formulas. But that's going to be it. I don't have any more time. So I'll see you guys in class. Let me know if you guys have any questions, and good luck on your skill check, okay? All right.